Today's video lesson is on inscribed angles. Objectives: to find the measures of an inscribed angle, to find the measure of an angle formed by a tangent and a chord. An angle whose vertex is on the circle and whose sides are chords of the circle is an inscribed angle. An arc with endpoints on the sides of an inscribed angle and its other points in the interior of the angle is an intercepted arc. So in the diagram I have inscribed angle C with intercepted arc AB. You have to understand that angles formed by intersecting lines have a special relationship to the arcs the intersecting lines intercept. In this video, we are going to study arcs formed by inscribed angles. So, inscribed angles, they're not the central angle. And there is a relationship between the inscribed angle and the intercepted arc measure. And we're going to see that in this video. So we have the inscribed angle rule, which says that angle B is half the measure of arc AC. So remember MAC, remember it's arc measure, where just two letters is arc length. Okay, the reason why this is the case, because if I have my central angle, and I'll draw my central angle in this case, so I'm going to call point, this is the O, so O is the center. If this is 50, then angle B would be 25, okay, because the intercepted arc is also going to be 50, okay. So that's how we know that it's going to be half the intercepted arc, angle B, which is the inscribed angle, okay. So again, angle B is inscribed angle, therefore intercepted arc AC. So I know that the inscribed angle is half of its intercepted arc. So again, this is the inscribed angle. And MAC, this is the measure of arc AC, and this is the intercepted arc. Okay. So if this is 100, this would be 50 degrees. Because remember that arc measures are in degrees, not in feet or centimeters. And you can go vice versa. If I tell you that angle B is 30, I know the arc measure will be 60. So let's put this into play with this example. Okay, I have intercepted arcs, I have inscribed angles. I need to find the measure of the arcs or the inscribed angle. Don't forget that central angles are also equal to arc measures, and don't forget about diameter and radius. So notice that QT is not a diameter because it doesn't go through the center of the circle. So what I want to do is I want to start solving for my angle A by finding its inscribed angle. So how do I solve for arc PT? Well, arc PT is an intercepted arc formed by inscribed angle Q. That's a little too thick. Let's thin this line down. So here's angle Q is inscribed and forms arc PT. So if the inscribed angle is 60, I know that PT arc measure is double it. So since I know angle Q is equal to half of the measure of arc PT. So angle Q is 60, half of A degrees, so I know that A is going to be 120 degrees. So the key here is to find the inscribed angle that goes with the arc that you're trying to find, or vice versa. Try to find the angle that goes with the arc or the arc that goes with the angle. Okay, so let's try to solve for B. Well, for angle B, I'm just going to now try to find my intercepted arc. So here's B. So I now know that A is 120. So notice that inscribed angle B forms arc. Let's do a different color. Let's go with blue. So I have arc PS. Well, the measure of PS is 120 plus 30. So there's your arc addition from a couple video lessons ago. So I know that the measure of arc PS is equal to 150. So I know that angle R is equal to half the measure of arc PS. Now some of you might be asking, how come I'm not using PTS? Remember that we use 2 letters to name a minor arc, which is less than half a circle. You use 3 letters to name a major arc, which is greater than half a circle. So PS is a minor arc because it's less than 180, because it was 150. So B is equal to half of 150. So B is equal to 75 degrees. Let's try another one. I'll enlarge it. So I know what's the measure of angle A. Well, you should notice that BC is a diameter. And remember, there's 180 degrees in a semicircle. So I know that the measure of arc BC is 180 degrees. I want the measure of angle A. Okay? So there's angle A. I need to find the intercepted arc. So the intercepted arc is BC. Well, if the intercepted arc is BC, and I know BC is 180, I know the inscribed angle is half its intercepted arc. So I know that angle A is equal to half of its intercepted arc, which is BC. So angle A is going to be half of 180. So therefore, half of 180 is 90 degrees, and that is the measure of angle A. So inscribed angles, find the intercepted arc, and it's half of it. If you have the intercepted arc, okay, you can find the inscribed angle. If you have the inscribed angle, double it to get the intercepted arc. So let's try another one. I want to find all of these measurements. Okay, I want to find angle A, angle B, angle C, angle D. Well, let's start with angle A. Well, if I have angle A, it's inscribed because the vertex is on the circle and it's formed by 2 chords. So I'm going to draw on my red lines. So here are my red lines. So, okay, I have my angle A is formed by arc B, C, D. So angle A will be half of the measure of arc BCD. The reason why I'm using 3 letters is because I noticed that arc BCD is 190 degrees. That's a major arc. So angle A is equal to half of 190. So half of 190 is going to be 95. So there's angle A, 95 degrees. So let's find angle B. So if I have angle B, I need to find its intercepted arc, which is formed by the chords that form angle B. So if angle B is here, I have arc AC. Okay? So angle B will be equal to half of its intercepted arc. So the intercepted arc is going to be AC. Well, AC is 154 because 64 and 90 is 154. So angle B is equal to half of 64 plus 90. Angle B is equal to half of 154. So angle B is equal to half of 154, which is 77. Let's solve for C. So, inscribed angle C forms arc DB. Okay, so I have arc DB is formed by inscribed angle C. There's my arc. So angle C will be half of the measure of arc DB. So angle C is equal to half of 64 plus 106. Angle C is going to be half of 64 plus 106, which is 85. And then now we can do angle D. There's two ways to do angle D. You can do the inscribed angle, or you know that ABCD is a quadrilateral and there's 360 degrees in a quadrilateral. So you could subtract 77, 85, and 95 from 360 and get angle D. But I'm going to use the inscribed angle rule. So I know that. Okay. For angle D, it's going to be half of the measure of arc. I'm going to have to do, the arc is from A, B, C. Why do I use three letters? Because it's greater than half a circle. So it's ABC. So angle D is equal to half of 106 plus 100. So angle D is going to be equal to, that's half of 206. So angle D is going to be equal to 103. And we can check. Okay. Check. We're going to do 103 plus 95 plus 85 plus 77. Does that equal 360? Let's check. So we're going to take out our calculators. 103, 77, 85, and 95, and it does. Yes. Why did I check it? Because ABCD is a quadrilateral. Quadrilaterals have 360 degrees for the interior sum of its angles. You also have some corollaries that go with inscribed angles. If you have two inscribed angles that are intercepted by the same arc, they're going to be congruent. An angle inscribed in a semicircle is a right angle. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So I'll do some quick examples for corollary 1. So I know that angle A and angle B are equal. Okay, I know A and B are equal. I'll even visualize it with the different color lines. Okay. Why? Because they both intercept the same arc CD. So there you go. The blue lines intercept arc CD. The red lines also intercept arc CD, therefore the inscribed angles are congruent. So there's corollary 1. Corollary 2 is very simple. The inscribed angle basically has the sides as endpoints of the diameter. Therefore, it has to be 90 degrees because half of 180 is 90. And then for corollary 3, corollary 3, you have a circle and you have a quadrilateral inscribed, meaning that you have a four-sided figure inside of a circle and all four vertices are on the circle. I know that 1, 2, 3, 4. I know that angle 1 plus angle 2 will be 180. Angle 3 plus angle 4 will be 180. That's only if it's quadrilateral. It doesn't work with anything else. It doesn't work with a triangle. It doesn't work with a pentagon, hexagon. It's only for a quadrilateral where vertices are on the circle and the circle is inscribed, or the quadrilateral is inscribed. So let's actually add this into our notes. So example 1, I know angle 1 is inscribed in a semicircle. So by corollary 2, angle 1 is a right angle, so the measure of angle 1 is 90 degrees. So I know angle 1 is 90. Well, you should also notice that this angle is going to be 20, and this angle right here is 35. And this angle is 90. And if this right here, if A to B is 40, you should know that C to D is 180, or sorry, C to B is 180. So if this is 40, you know that this is 140. So C to A is also 140. And don't forget there's 360 degrees in a circle. So with B, I have angle 2 and the 38 degree angle intercept the same arc. So by corollary 1, the angles are congruent. So angle 2 is also 38 degrees. Okay, I'll show you. Okay. So 38 degrees intercepts this arc. I'll label it for you. A, B. Angle 2. Angle 2 also intercepts arc AB. Therefore, angle 2 is also 35 degrees. Or sorry, 38 degrees. So this is also 38. So 38 times 2 is 76. So you also know that this is 76 degrees. So those are two examples using the corollaries. So in the diagram at the right, what's the measure of each numbered angle? So here's corollary 3. I know that opposite angles are going to be supplementary. Why? Because I have a quadrilateral inside of a circle, and the vertices are on the circle. So let's find our angles. Okay, I know that, okay. I'll label AB is a diameter because it goes through the center of the circle. So in a diameter, you have to have 180 degrees in its arc. So I know, I'll label this D. I'll label that C. I know A to D will be 100 degrees because ADB is a semicircle. So therefore, the two arcs have to add up to 180. Okay. CB and CA have to add up to 180. So 180 minus 60 is 120. So AC arc is 120. So now that I have all my arcs, I can find all my inscribed angles. So notice that angle 1 has an intercepted arc of AB, so I know that this is going to be 90. And opposite angles, so I know angle 1 plus angle 3 is 180. So angle 1 is 90, so this is 90 because it equals 180. So angle 1 is 90, angle 3 is 90. Now, with angle 4, angle 4 has intercepted arc CD. Well, the arc of CD is 60 and 80, which is going to be 140. So if I know that this arc CD is 140, okay, I know angle 4 is equal to half of the measure of arc CD. So angle 4 is equal to half of 140. So angle 4 is 70. Since I have angle 4, I know angle 4 plus angle 2 has to equal 180. So if angle 4 is 70 plus angle 2 is 180, I know angle 2 is 110. So there's a lot going on. You have to know a lot of your rules about arc measures, semicircles, inscribed angles and how it relates to the intercepted arc. And now corollary 3 with inscribed angles says that quadrilateral, inside of a circle, vertices on the circle, opposite angles are supplementary. You also have the tangent chord rule. Okay, I call this the tangent chord rule. Which states that the inscribed angle C is going to be half of BDC. Okay, this refers to this picture right here. So I'm saying that this angle right here is half of the arc BDC. And then I can also have that angle C is equal to half of the measure of arc BC. So there, you could do it both ways, major or minor. And this is when you have a tangent, okay, and a chord intersect. So we have a tangent and a chord, therefore the angle formed by those two is half its intercepted arc. So SR is a tangent, so don't assume angle Q is 90. Angle Q is 90 if PQ is diameter, because a tangent, don't forget, is perpendicular to a radius. Here I'm saying I have a tangent and a chord, so the angle formed, okay, is half the intercepted arc. So if PMQ arc, PMQ, so I'm saying this arc, let's do a different color. So I'm saying from PMQ, this arc measure, right here in blue, is 212. So my angle formed by the tangent chord in red here is half. So half of 212 is 106. So this is 106. You should know that these two angles are linear, so I can just subtract 106 from 180 and get 74. So this is 74. And if this is 74 and I multiply it by 2, I get 148. So the measure of arc PQ is 148. Angle PQR is 74. Angle SQP is 106. and they gave us the measure of arc PMQ. Let's try it again with a different example. I want the values of x and y. So knowing that KJ is tangent to circle O, what's the value of x and y? Well, if I have a tangent, I know that I can find arc measures. So first of all, what I'm going to do, I know that this arc right here, JL, okay, I'm going to highlight JL. I know that the measure of arc JL is going to be equal to 2 times the inscribed angle of Q. So the measure of arc JL is 2 times 35, so the measure of arc JL is 70. So I know that this purple arc is 70. So I know that this arc from J to L is 70. So if that's 70, this arc that they're trying to find in red, let's use red, is going to be half of the intercepted arc. Well, this red angle intercepts, let's highlight it, the same arc as angle Q. So angle Q, or sorry, not angle Q. So I have this angle J. This angle J is going to be half of the same arc. So angle J is also 35. It's kind of messy. Hopefully you can see that. Because again, J to L arc measure is 70. Therefore, let's highlight, let's use some. So here is the angle. So I want this angle. And I already found the arc, okay? Remember, we found this arc. This arc is 70. So if this arc is 70, this angle that's inscribed will be half of it. So angle LJK is equal to half of the measure of arc JL. So the measure of LJK is equal to half of 70, which is equal to 35, and that is x. Now let's solve for y. Well, if I'm going to solve for y, y is forming intercepted arc QJ. Well, if I know that this is 70, I know the QJ arc is 110 because I know from Q to L is a semicircle. So Q to L is a semicircle. I know J to L is 70, therefore J to Q is 110 because 110 and 70 is 180. So Y is half of 110. So Y is equal to half of the measure of arc QJ. So Y is equal to half of 110. So that's going to equal to 55 degrees. And that concludes this video lesson. If you have any questions, leave a comment. See me in class, and practice, practice, practice.